to Part 3 of our Environmental Studies course, where we'll explore environmental pollution and disaster management. In this module, we'll cover various types of pollution including air, water, soil, noise, thermal, and radiation pollution. We'll also discuss solid waste management, pollution prevention, and disaster management. Environmental pollution occurs when harmful substances or pollutants enter our natural environment. These pollutants can be chemical, physical, or biological in nature, and they cause adverse effects on ecosystems, biodiversity, and human health. Understanding pollution is crucial for developing effective environmental protection strategies. Air pollution comes from both human activities and natural sources. Industrial emissions release sulfur dioxide and nitrogen oxides, while vehicles emit carbon monoxide and hydrocarbons. Agricultural activities contribute through fertilizer use and livestock emissions. Natural sources include volcanic eruptions and forest fires, all contributing to our air quality challenges. Air pollutants are classified into two main categories. Primary pollutants are directly emitted into the atmosphere, like carbon monoxide and sulfur dioxide. Secondary pollutants, such as ozone and smog, form when primary pollutants react with sunlight or water in the atmosphere. Air pollution's impact on the biosphere is far-reaching. In humans, it causes respiratory diseases and cardiovascular issues. Plants and crops suffer reduced yields, while water bodies face acidification. Perhaps most significantly, certain pollutants contribute to global climate change, affecting entire ecosystems. Weather conditions play a crucial role in air pollution dynamics. Temperature, wind, and humidity affect how pollutants disperse and concentrate. A particularly important phenomenon is thermal inversion, where cold air gets trapped beneath warm air, causing pollutants to accumulate near the ground. Managing air quality involves both monitoring and control measures. The Air Quality Index helps us measure pollution levels, while various control methods, from regulations to technological solutions like filters and scrubbers, help reduce emissions. Public awareness and clean energy adoption are also vital strategies. Water pollution manifests in three main forms. Chemical pollution involves toxic substances and heavy metals. Biological pollution includes harmful pathogens, while physical pollution encompasses solid waste and sediments that affect water quality. Water pollution originates from multiple sources. Domestic wastewater contains detergents and organic matter. Industrial effluents contribute toxic chemicals, while agricultural runoff introduces fertilizers and pesticides. Mining activities and marine dumping further compound these water quality challenges. Soil pollution occurs when harmful substances contaminate our soil, making it unsuitable for agriculture and wildlife. This form of pollution disrupts the delicate balance of soil ecosystems, affecting microorganisms and natural processes that are essential for healthy soil functioning. There are 5 major types of soil pollution. Industrial pollution introduces heavy metals and chemicals. Agricultural pollution comes from excessive fertilizers and pesticides. Urban waste contributes through landfills, while radioactive contamination creates long-lasting effects. Mining activities add toxic compounds like sulfuric acid and cyanide. To combat soil pollution, we employ several strategies. Sustainable agricultural practices reduce chemical inputs through organic farming and integrated pest management. Proper waste management, including recycling and composting, helps prevent soil contamination from landfills. Additional control measures include phytoremediation, where specific plants help clean contaminated soils by absorbing heavy metals. Industrial regulations ensure responsible waste management, while containment zones around industrial areas prevent the spread of pollutants. Noise pollution refers to excessive or unwanted sound that disturbs our environment. Whether from transportation, industrial activities, or urban settings, persistent loud noise can significantly impact both human health and wildlife behavior. The impact of noise pollution on human health is significant. It can cause hearing impairment from prolonged exposure, increase psychological stress, disrupt sleep patterns leading to fatigue, and even contribute to cardiovascular problems through long-term exposure. Noise pollution severely affects wildlife by disrupting communication between animals, interfering with mating calls, and forcing habitat displacement. In human contexts, it reduces productivity by affecting concentration and efficiency in work and educational environments. Controlling noise pollution involves urban planning strategies like zoning regulations and creating green buffers. Technology plays a crucial role through soundproofing and designing quieter engines and equipment. Additional control measures include public awareness campaigns to promote responsible noise practices and legislation enforcement. This includes setting noise standards and establishing quiet zones near sensitive areas like hospitals and schools. Thermal pollution occurs when temperature changes in water bodies negatively affect aquatic environments. This type of pollution primarily results from industrial activities, power plants, and deforestation, leading to significant disruptions in aquatic ecosystems. Thermal pollution has several key causes. Power plants and factories discharge heated water used for cooling into water bodies. Deforestation exposes soil to direct sunlight, increasing surface temperatures. Urban development creates heat-absorbing surfaces, and climate change amplifies these effects by raising overall water temperatures. The effects of thermal pollution are far-reaching. Warmer water holds less dissolved oxygen, leading to hypoxic conditions. Aquatic ecosystems face disruption as temperature changes shock marine life and alter breeding cycles. These conditions can also trigger harmful algal blooms, further degrading water quality. To control thermal pollution, several methods are employed. Cooling ponds and towers help dissipate heat before water discharge. Industries can recycle heated water within their processes. Natural solutions like planting trees provide shade for water bodies, while regulations limit the temperature of discharged water. Radiation pollution involves the release of harmful radioactive substances into our environment. This particularly dangerous form of pollution can come from various sources and poses serious long-term risks to living organisms due to its persistent nature. Radiation pollution stems from multiple sources. Nuclear power plants can release radiation through accidents or waste management issues. Nuclear weapons testing, medical procedures, and industrial processes contribute to radiation exposure. Mining of radioactive elements and natural sources like radon gas also play a role. Radiation exposure can cause severe health issues in humans, including increased cancer risk and genetic mutations. High doses can lead to radiation sickness, causing organ damage. In ecosystems, radioactive particles can accumulate in the food chain, affecting multiple species. The impacts of radiation pollution are particularly concerning because they can affect future generations. Genetic mutations can lead to birth defects, while contaminated environments may remain unsafe for extended periods, affecting both wildlife and human habitation. Controlling radiation pollution requires strict measures. Proper disposal of radioactive waste in sealed containers and deep geological repositories is essential. Strict regulations, protective equipment, and emergency response plans help minimize risks. Some experimental methods like phytoremediation show promise for cleaning contaminated areas. Solid waste management involves systematically handling discarded materials. This comprehensive process includes collection, treatment, and disposal of waste, with the goal of protecting environmental health and minimizing community health risks. Solid waste comes in various forms. Municipal solid waste includes household trash and packaging. Industrial waste can contain hazardous materials. Biomedical waste requires specialized handling. Agricultural waste encompasses crop residues and animal byproducts, while e-waste contains electronic components requiring special disposal. Solid waste management follows a systematic process. It begins with collection and segregation of different waste types. The waste is then safely transported to processing facilities. Processing includes recycling and composting, followed by final disposal through methods like landfilling or incineration. Various methods are used for solid waste disposal. Landfills remain the most common but require careful design. Incineration reduces waste volume through burning. Recycling and reuse conserve resources, while composting transforms organic waste into useful fertilizer. Anaerobic digestion produces biogas and nutrient-rich slurry. Managing solid waste faces several challenges. Rapid urbanization increases waste generation beyond management capacity. Public awareness often lacks regarding proper waste disposal. Infrastructure limitations and potential health hazards from mismanaged waste create additional complications. Several solutions can improve waste management. Waste-to-energy programs create value from waste. Extended producer responsibility makes manufacturers accountable. Public awareness campaigns, government regulations, and innovative recycling technologies all contribute to better waste management. Pollution prevention, or P2, focuses on stopping pollution before it begins. This proactive approach is more effective than cleaning up contamination after it occurs. It benefits both environmental and public health, while often reducing costs associated with waste management. The key principles of pollution prevention include source reduction to minimize waste generation, resource conservation through efficient use, green chemistry practices, and sustainable production methods. These principles guide organizations in reducing their environmental impact. Various methods help prevent pollution. Cleaner production techniques reduce emissions. Energy efficiency measures cut power consumption. Water conservation and waste minimization strategies reduce resource use. Using environmentally friendly materials helps prevent harmful impacts. Different sectors require specific pollution prevention approaches. Agriculture can adopt organic farming and efficient water use. Manufacturing benefits from lean practices. Transportation sector focuses on cleaner fuels, while construction emphasizes sustainable materials and waste management. Pollution prevention offers multiple benefits. It protects the environment by reducing emissions and waste. Organizations save costs through lower treatment and disposal needs. Public health improves with better air and water quality. Companies also benefit from improved regulatory compliance and enhanced reputation. Successful pollution prevention requires comprehensive strategies. Employee training ensures proper implementation. Life cycle assessments identify improvement areas. Research and development create innovative solutions. Public involvement and government incentives encourage wider adoption of preventive practices. Disaster management is a strategic approach to handling both natural and human-made disasters. It involves preparing for, responding to, and recovering from catastrophic events. The goal is to minimize impact on human lives, property, and the environment through well-planned measures. Natural disasters come in various forms. Earthquakes cause sudden ground movement and structural damage. Floods submerge land and disrupt communities. Cyclones and hurricanes bring destructive winds and rain. Droughts affect water supply and agriculture, while volcanic eruptions release hazardous materials into the environment. Human-made disasters include industrial accidents like chemical spills and nuclear leaks. Terrorist attacks threaten public safety. Transportation accidents can cause significant casualties. Both urban fires and wildfires pose serious threats to communities and ecosystems. Disaster management involves key phases. Mitigation focuses on reducing future disaster impacts through measures like building codes and hazard assessment. Preparedness includes emergency planning, drills, and public education to ensure readiness. The response phase involves immediate actions during and after disasters, ensuring safety and providing essential aid. Recovery focuses on restoring normalcy through infrastructure repair, healthcare, and community support. The disaster management cycle is continuous. Preparedness leads to response, followed by recovery, then mitigation, before returning to preparedness. This ongoing cycle helps communities become more resilient and better prepared for future disasters. Key aspects of disaster management include early warning systems to predict hazards, risk assessment and mapping to identify vulnerable areas, and community involvement to enhance local preparedness and response capabilities. Technology plays a vital role through GIS and monitoring tools. Capacity building and training prepare responders and communities. Post-disaster psychological support helps communities recover from trauma. Successful disaster management relies on preparedness and planning, effective coordination between agencies, rapid and flexible response capabilities, and ensuring fair distribution of aid and resources to all affected populations. Multiple agencies coordinate in disaster management. Local authorities provide initial response. National agencies form policies and mobilize resources. International organizations and NGOs offer additional support, while military forces assist in search and rescue operations. Disaster management faces various challenges. Inadequate infrastructure hampers response efforts. Resource limitations affect recovery. Communication disruptions complicate coordination. Climate change increases disaster frequency, while public awareness often remains insufficient. Thank you for joining this part of our environmental studies series. Don't forget to like and subscribe for more tutorials on other exciting topics.